Hey boys and girls, so today we're going to be going over Unit 7, Lesson 2, which is graphing quadratics with the leading coefficient not equal to 1. Okay, again, that's going to be that A value, that number that's right in front. And you can already see in the do now, my leading coefficient is not equal to 1. That's what we're going to be working on for today. All right, make sure that your name is written down at the top. And let's jump on in. So again, as we look at the do now, it says, write the table of values for the quadratic function y equals 2x squared minus 1 below. Then we want to plot those points on the set of axes provided. So there's a few important keywords here that I just want to highlight out. One of them would be quadratic. Okay, another word for quadratic would be a parabola. And we know that a quadratic or a parabola can look like a happy face or it can look like a frowny face, depending on my leading coefficient. So as I look here, my leading coefficient is a positive 2. Again, because it is positive, I know that when I graph this, it should look something like a happy face, all right, because that leading coefficient is positive. So now I'm going to grab my handy-dandy graphing calculator and I want to type in that function. So I'm going to go to y equal, and I'm going to press 2x squared, all right, minus 1. I could press graph if I want to see what the function is going to look like. There it is. There's my happy face. All right, that U shape. Or what's going to help me even more to fill out this table would be looking at the actual table itself. That's a blue word, so I have to press this blue button to activate it. So I'm going to press second graph, and that's going to pull up my XY table. Now, do you notice how the point 0, -1 is right in the middle? Yeah, I want to make sure that my table looks exactly the same. I want that 0, -1, which is right here, to again be right in the middle. So it looks like this is the table that I want to copy over onto my do now. So I'm going to write down these coordinate points. So we have -3, 17. Next is -2, 7. Then we have -1, 1. And then we have our 0, -1. Now it's going to flip. Now we have 1, 1, 2, 7, and 3, 17. All right, here we go. Anytime that I am graphing a quadratic or I'm graphing a parabola, this is how I want the table that I'm copying over to look like. I want it to be symmetric. Woogie, woogie, woogie. All right, so at the top I have 17. At the bottom I have 17. At the top I have 7. At the bottom I have 7. Right, 1, 1. And then this point that's located right in the middle, this is going to be called my vertex. Okay, AKA it's also known as my turning point. All right, so just be aware of that. So as I look at the do now, it says I want to write down the table of values. Check, I did that. Then I want to plot these points on the set of axes provided. So let's go ahead and do that. So if I try to plot -3, positive 17, it's going to go off my graph. So I can't plot when y is 17. These values only go to positive 10 and -10. And the same thing again, positive 10 and -10. And that's okay. So I just won't plot this first point or this last point. I'm just going to plot these guys in the middle. All right. Don't forget, we know that x moves left to right, and we know that y moves up and down. Anytime I'm plotting a point, I always start at the origin. So since I can't plot the first one because it's not going to fit, I'm going to jump down to the next point here, which is -2, 7. -2, x goes left and right, so -2 would be to the left 2. 7, positive 7 would be up 7. That would be located right here. Next, from the origin, I want to go to the left 1, up 1. Again, I'm going left or right, up or down. Negative goes to the left, positive goes up. Here's my point, -1, positive 1. And then after that, we have 0, -1. Again, from the origin, 0. I am not going to go left or right. 0 tells me to go nowhere. All right, so I'm just going to go down, down 1 because it's a -1. So this would have been my point, 0, -1. And now again, you're going to see that flip-flop because this is symmetric. Woogie, woogie, woogie. So again, from the origin, I'm going to go to the right 1 because this is positive, and then up 1 because again, it's positive. And then one more time, 2, 7, that's to the right 2, up 7. And now I want to go back and I want to connect those points together to get that U shape, to get that smiley face that I wanted to graph. All right, it looks like the first part is done. Now I want to jump down to the questions underneath. It says state the zeros. All right, here we go. If I look at my graph, this is something that we had gone over in the vocabulary yesterday. If I want to state the zeros, another word for zeros would be solutions, roots, or really it's my x-intercepts. Okay, all four of these words are asking you to find the exact same thing. So if this is my x-axis, I'm just going to highlight it out, I am again looking for my x-intercepts, or my zeros, or my solutions, or my roots, right? All of those words mean the exact same thing. So as I look on this graph, do you notice here how I have 1, 2 roots? I'm just going to draw an arrow. I want you guys to label this with me for practice on your notes. This would be known as a root, okay? Or let's put a slash, a 0, because that's really what it's asking me to find. Again, this is going to be known as a root. Let's put a slash or a 0, okay? I could put all 4 words, but I don't want to take up too much time here, okay? But that's all of my roots, my zeros, my solutions, my x-intercepts. So I have 2 of them, but it's asking me to state what those zeros are going to be. Do you notice how they're not exact points? Like we plotted -2, 7, -1, 1, 0, -1. Are you with me? But we never plotted these exact points, and that's okay. I'm just going to eyeball it here, okay? There is a way to find it exactly on the calculator, but again, just for right now, we're just going to eyeball it out. So I'm going to say this is about when x is -0.5, because I'm about halfway between 0 and -1. And I'm going to say my other x-intercept is when x equals +0.5. Because again, I'm right in between where x is 0 and +1 as well. Now this is only one way to write the zeros. I could have also wrote it as a coordinate point. This would have been the point -0.5, 0. And this would have been the coordinate point 0.5, 0. All right, don't forget it's going to be x, y, again, x, y. We know that our x value is -0.5, so x comes first. The y is 0 because I'm not going up or down. I am staying on the x-axis. All right, so that would have been the zeros. Next, it says state the minimum or maximum of this graph. Well, think of this as a roller coaster, okay? You read left to right. So think about getting on this roller coaster to the left and then whoop, making your way over to the right. I want to ride that roller coaster. So if this is me and I'm getting on at the top up here, all right? As I'm riding this roller coaster, it looks like right off the bat I have a downward spiral here. I'm going straight down. So if I'm going down, would you say that's going to be a minimum or a maximum? Yeah, that's definitely going to be a minimum, okay? This would be the lowest point on the graph. So state the minimum. What is that minimum value? It's actually my vertex. It's my turning point. This was 0, -1. So I'm going to write that down. And then last but not least, it says compared to the graphs we had yesterday, how is the U-shape different today? Well, if I were to graph just x² -1, it would look something like this. Let me highlight that out in a different color. Okay, x² -1 would look something like this. Okay, and again, this is when y equals x² -1. All right, it would come down here, whoop, and then swirl back up. So it's asking how do they compare? Well, if this is what we were graphing yesterday in orange, and this is what we're graphing today in purple, how are they different? Well, this looks just a little bit more squeezed up, a little bit skinnier than the graph that we had talked about yesterday. So that's literally what I'm going to write. How is the U-shape different? I'm going to say that this is a skinnier, but that's not a real vocabulary word in algebra. It's actually called narrow. It would be more narrow. When you see the keyword narrow, you can think it's skinny, but this is the key word you would see on the Regents. This is the word that you want to memorize and use in your notes on future tests and quizzes and things like that. All right, and that's what we're going to be working on today. So sometimes your graph can be a little bit skinnier, like we're seeing right now, but sometimes it can actually be a little bit wider as well, which we're going to see later on. All right, meet you on the next page. All right, as we look at example 1, it says graph the function y equals negative 2x squared plus 4x on the set of axes below. All right, let's do that first so then we can eventually answer these questions on the side. So at any time that I am graphing a linear function, right, a line, or a quadratic, a parabola, something like this, if it's an absolute value, anytime you are graphing, you always want to copy down that XY table somewhere on the side. Okay, that way in case you make a mistake, you plot a point in the wrong spot, this is a way for the teacher to check, oh, well, you understood what the question was asking, you just made a mistake when you were plotting those points. All right, it's just a way for you to possibly earn some credit on the side. So here I go. I'm going to turn my graphing calculator on. I'm going to press y equal, and then I'm going to type this in. So we have negative 2x squared plus 4x. Again, I can press graph if I want to see what it's going to look like. Oh, what do you guys notice here? Is that a happy face or a frowny? He looks sad. You want to know why? Yeah, you already knew. It's because this leading coefficient is not a positive 2. It's a negative 2. Negative is sad. It's going to be an upside down U. All right, so I knew it was going to look like that before I even graph. So just be aware of that. But again, I want to graph this function, so I want to go to the table. I'm going to press second graph to get there. And then don't forget what we talked about before. I know that quadratics, these x squared functions, okay, look like happy faces or frowny faces because they're symmetric. All right, so I want to scroll here until my xy table is symmetric. And now I can see that it is. These match, right? My negative 6's match, my 0's match, my 2 is in the middle. I'm ready to rock. So this is the xy table I want to copy down. So we have negative 2, negative 16, negative 1, negative 6, 0, 0, 1, 2. Now it's going to flip-flop on me. Now I have 2, 0, 3, negative 6, and 4, negative 16. All right. Here it is at the bottom. Make sure that you guys copy all of those points down. All right. And then one more time, I can see here that it is symmetric. Woogie, woogie, woogie. Because again, I got my negative 16s, my negative 6's, my 0's. And then what was this point right in the middle called? Yeah, this was called our vertex. Label this with me, boys and girls. This is our vertex, aka it's also known as your turning point because it's literally where the graph is going to start turning. If it's going down, 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 this is my turning point. Now it's going to start going up, 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 up. All right, so here it is. So now let's come back up to the top here and start plotting some of these points. If you notice again, all right, we're coming up with that issue here. This y value is negative 16. My x's only go to positive 10 and negative 10, and my y's only go to positive 10 and negative 10. So if any of these values are more than 10, I won't be able to plot them. But that's okay. So I'm just not going to plot that very first point. I'm going to skip down to negative 1, negative 6. One more time, x moves left and right, y moves up and down. You are always starting at the origin. So from the origin, negative is left, negative is down. So I'm going to go to the left 1, down 6. 1, 2, 3, 4, 5, 6. Here we go. Negative 1, negative 6. Next is pretty easy. 0, 0. So that's going to be the origin. I'm going to put a point right here. And then we're at our vertex, which is 1, 2. These are both positive. Positive goes to the right 1, up 2. To the right and up. That's both positive. And now I'm going to flip. Now we got 2, 0. So I'm going to go to the right 2. And I'm not going to go up or down. That's 2, 0. And then last but not least, the last one that we can plot here is 3, negative 6. So one more time, from the origin, I'm going to go to the right 3, but then down 6 because negative is down. Here we go. I'm going to connect these babies together. Put arrows at both ends because I know that my graph goes on forever. And now I'm ready to start answering some of these questions. It says, does the parabola open upward or downward? Well, silly goose, we already said it opens downward. Also because there's a negative. And when I pressed graph, I could see it was going down. When I plotted the points, it's going down. So many different ways that I can tell it is going downward. Let's write this on our notes. Next, what's the vertex? AKA, what's my turning point? Well, I can either get my vertex or my turning point right from the graph. Let's label this together. This is my vertex, again, also known as my turning point. But instead of looking at the graph, I could have also looked at the XY table that I copied down. All right, that point where it's going to start flipping on me, that's going to be my vertex as well. So wherever you want to get that answer is totally up to you, but the vertex is definitely 1, 2, x, y, 1, 2. Next, it says, what is the minimum or the maximum of this graph? Again, think of it as a roller coaster. You read left to right, so this is where I'm getting on. I'm riding the roller coaster. Eventually, I'm getting off. So again, is there a minimum or a maximum? Well, if this is where I get on, it looks like I'm going up, 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 until I hit the top. The top would be a maximum, all right? But it's asking me what is the maximum? What is this point? Well, again, I can either write it as a point, which we already said before was 1, 2, or the maximum is a height, right? So my height is calculated by looking at my y-axis. If I have a maximum, I want to see how high I am. That's y, going up. If I have a minimum, that's my lowest point. That's going down. Again, that would still be y. So I can either write my answer as 1, 2, or I could say it's when y equals 2. Because don't forget, this is a coordinate point, x, y. So both of these are correct, one or the other. As we keep reading here, it says how many roots or zeros or solutions do we have? Well, don't forget there's actually another key word that you could think of when you see these words together, and that's going to be x-intercepts. All right, now when you guys take a test or a quiz or the Regents, you're most likely only going to see one of these words. It might ask you what's the roots, what's the zeros, what's the solutions, or what's the x-intercepts. Okay, it's never going to really ask you all of these together. You have to memorize they're all asking you the same thing. So again, if I want to look at where my roots would be, that's going to be really looking at my x-axis here, which I want to highlight out. So again, if I want to see where my roots or my zeros or my solutions are, that's where I want to check. I can see that my graph hits my x-axis 1, 2 times. So how many roots do I have? I have 2 roots. And then it says, what are they? All right, well, I can see this is 2 coordinate points. This is the point 0, 0 because it's on the origin, 0, 0. And this is the point 2, 0, 2, 0. Okay, I can also write these because I'm really looking for the x-intercept as x equals 0 or as x equals 2. Okay, one or the other. I don't need all of these, okay? So either write it as a coordinate point, like this, or write it as x equals like this. Both are correct. And again, x-intercepts, this is my x, this is my y, here's x, here's y. So this is when x equals 2, when x equals 1, all right? And then I want to just label that on my graph here. This is going to be my root. Here is my other root. And then last but not least, it says, what is the axis of symmetry? Don't forget, we went over that really neat trick. When I see x, axis, that tells me it's going to be an x equal equation, all right? And because it's x equal, that means I want to look at my vertex, all right? It's pretty cool. So as I come over and I look, well, here's my vertex. I know that if something is symmetric, woogie, 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 that means I really want to cut it right down the middle. I want to cut it in half. So I'm just going to go back to my graph here, and I want to highlight out a line that's going to cut my parabola, this quadratic, in half. And I can see it's going to go right through my vertex. That's why I'm supposed to look at my vertex. All right, again, that line goes on forever. This is where my axis of symmetry is going to be located. Well, if it's an x equal equation, what x value am I hitting? 1. All right, and I could have gotten that by looking at my actual vertex. What does x equal? 1. So my vertex is the equation x equals 1. All right, questions, comments, concerns? All right, cool. Meet you on the next page. All right, boys and girls, here we go for example 2. So I went ahead and I just found my XY table. I copied it over. Okay, I'm going to show you guys this in 1 minute. At first, I just want to go over how I typed this into the calculator. So if you notice, my leading coefficient here is a fraction. It's that positive 1/2 x squared. So if you have a graphing calculator at home or the graphing calculator app, if you press this alpha y equals button, so alpha y equal, do you notice how my first choice is a fraction? So this is just one way. If I press enter, I could have typed in 1, arrow down, 2, and then arrow out. That would have just been the fraction 1/2. Then I could have done x squared. All right. Another way I can type in a fraction, which a lot of you might not use, and that's okay. When I have a fraction, that's really the division symbol that I'm using. So with parentheses, I could have done 1 divided by 2, okay, and then typed in x squared. Okay, so either way, whatever is easier for you to work with, both ways of typing in it are correct, so just be aware of that. Then we would have had minus 4x plus 6. When I go to my table and I scroll because I want to look for that balance, do you notice how I have decimals at the top and the bottom? I have some decimals in the middle. All right, but then I have a whole number, right? 2, 0. Whole number, 4, -2. Again, another whole number, 6, 0. So this is the table that I copied over. All right, I copied over 2.5 as a fraction. All right, because if you use the alpha y equal, it'll give it to you in a fraction form. If you use the 1 divided by 2 method, it gives you it in the decimal form like you just saw. Okay, but both are correct. This is the table I copied over. Okay, I'm still seeing my symmetric table here. But when it came time for plotting, I only wanted to plot the nice looking points. So I only plotted 2, 0, 4, -2, which was my vertex, and I also plotted 6, 0. As long as you have 3 or more points, you're going to get full credit. You'll be good to go. So again, this is the table I copied over, but those were the points that I plotted because I wanted nice looking points so I could go back and connect and form that parabola with. Now, if I want to start answering the question, it says, does this parabola open up or down? Well, silly goose, this is going to be a positive leading coefficient, so of course it's going to open upward, but I would have also seen that as I plotted those points, so I'm going to just write that down, upward. What's the vertex? Well, the vertex is my turning point. It's right here. Let's label that on our graph together. So again, that turning point was 4, -2. I can always get it right here from my table. Next, it says, what's the maximum or the minimum of the graph? Well, just like a roller coaster, I'm getting on, I'm riding it. So here I am. I read left to right. I'm getting on at the left, and I'm riding it down, 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 down. So it would be a minimum. This would be the lowest point on my graph. But it asks, what is that point? Well, it's the vertex. The vertex is 4, -2. But I could have also wrote it as y equals -2 because, again, don't forget, if I have a maximum that's going up, the y-axis goes up. If I have a minimum that goes down, the y-axis goes down. That's why I can also write it as a y equal. Next, it says, what are the roots, the zeros, or the solutions? Well, another way of writing that would have been, what are the x-intercepts? Okay, we talked about this. I'm going to highlight out my x-axis to find my x-intercepts. I can see that my parabola, my graph here, is hitting it 1, 2 times. So I have 2 roots, or 2 zeros, or 2 solutions. And what are these going to be? Well, this is the point 2, 0. And this is the point 6, 0. I could have also wrote this as x equals 2 or x equals 6. Okay, so either write it as coordinate points or as x equal. Because don't forget, this is x, y. Again, this is x, y. And I could have also found those points, boys and girls, right from my table. Anytime y equals 0, all right, that's going to be a root. And then last but not least, it says, what is the axis of symmetry? Well, don't forget about that neat trick we went over, AX for axis. That's going to be an x equal equation. And how do I find that x equal equation? By looking at my vertex, x vertex. All right, so with a highlighter here, let me pick orange. I'm going to just highlight out where my graph is symmetric, where I can cut it right down the middle, and it will look the same on both sides. So here I go. I'm going to just dash right through. Boom, boom, boom. All right, and I can see here that I'm hitting the x value, positive 4. So this is going to be the equation, x equals positive 4. All right, I want you guys to now try numbers 3 and 4 on your own. You can check back for those answers when you're done. I want you to do all the exact same steps that I just taught you in the video. And then again, you can check back when you're done. All right, boys and girls, here's the answer to example 3. So it says graph the equation y equals 3x squared minus 3 on the axis below. Before I even type this into my calculator right off the bat, I'm noticing again that a value, my leading coefficient, is a positive 3x squared. So I know that this is going to be opening upward. It's going to look like a happy face or a regular U before I even plot. All right, so again, now at this point I do want to type it in my calculator. This is the XY table that I had found. All right, this is what it should look like when it's symmetric. Woogie, woogie, woogie. So again, we have the 24 at the top and the bottom. We have our 9s, our 0s, and then we know that point right in the center, right in the middle, that's going to be our vertex, which is also known as our turning point. So I graphed, then I went back, and I made sure to identify my vertex. Then I wanted to start answering the question. So again, what is the vertex? X 0, negative 3. I could have found that by looking at the graph or just by looking at my XY table. Either way is up to you. Next, it asks, what is the minimum or the maximum of this graph? Well, just like a roller coaster, I'm getting on the left, and I'm riding it all the way down. If I'm going down, that's going to be a minimum. So I can either write it as a coordinate point or as a y equal, because again, if it was a minimum, I'm going down, the x-axis goes down. That's why it's a y equal. Same thing if it was a maximum. Maximum goes up, the y-axis also goes up. So again, it would still be a y equal. Next, it says how many roots, zeros, or solutions are there, and what are they? Anytime I see these keywords, I should also be thinking x-intercept. So I want to highlight out the x-axis. I can see here that my graph hits it 2 times, so I know that those would be my roots. All right, so I have 2 roots, and again, I can either write those roots as coordinate points, or I can write it as an x equal, because again, my roots are on the x-axis, so I can write them as x equals. But if it's easier for you, you can also write it as a coordinate point. And then the same thing, what is the axis of symmetry? Well, our faces are symmetric. The parabola is symmetric. If I cut it right down the middle with this orange highlighted line, you would see that it goes right through the origin, 0, 0. All right, so if I want to write this as an equation, axis has an x, so it should be an x equals, it's when x equals 0. And I can also get this from looking at my vertex. All right, if I look back up top, x does equal 0. And then we have example 4. Let's just flip and look here. Example 4, it says graph the equation y equals. We have our x squared minus 6x plus 9. Again, this is positive, so I know it's going to be opening upward. Same exact steps, boys and girls. I just copied down my XY table. I want it to be symmetric as I copy it over. And then one more time, these are just all of the answers that I got. All right. I hope you guys are doing great. If you have any questions, you could always message us in Canvas. We could set up a Google Meet, whatever it is that you need. And then last but not least, as we look at the very last page, that's going to be your homework. Okay, it's just this one question. Make sure that you answer it completely. Use the notes to answer these questions if you need to. All right. Have a great day.